In this lesson of 8.3, we're going to continue to look at triangle similarity. We're just going to add two different ways that we can do it now. In the last lesson, we just had angle, angle. Now we'll have side, 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 and side, angle, side. Though, remember, this is similarity, not congruence. SSS congruence theorem was one. SSS similarity is different. So even though they're different, they work kind of in the same type of manner. But instead of them having to be like congruent, like side, 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 congruence theorem said that every single side had to be exactly the same length. Now, as long as I have all three sides are proportional, they have the same exact proportion ratios, then they are similar to each other. So in this statement, you can see here they have the proportions set up, showing that they're all equal. Then the statement can be made that they are similar triangles. So in this first example, we're going to start to compare them. So if we look at it, the easiest way to start setting up which ones you want to see if they're proportional or not is to do like your smallest sides with your smallest side. So if I do AB, my smallest side of my triangle, I'm going to compare it with my other small side. So I can compare it with DE. And then I'm going to do my largest side. So then I have AB is my smallest, my largest is AC, and then my largest on DEF is going to be DF. And now I'm going to plug them in. So if AB is 8, DE is 6, AC is 16, and DF is 12. I can cross multiply or you can reduce to see about getting your same ratio. So if I cross multiply, I do 8 times 12, so I get 96, and then 6 times 16 is 96. This one checks out, so this would tell me that ABC is similar to DEF. The only other thing you might need to check, just to make sure, since we don't have an angle, we do have to do all the sides. So let's do one more sides to do the last one, BC compared to EF, and see if it would give us ratios as well. Because think about if we only did two sides, that doesn't follow the SSS similarity theorem, right? Okay, so we need to do the one last one. So BC in comparison, we can do it to either one of those sets. So I can do A, B, D, E again. So if I plug those in, BC is 12, EF is 9, AB is 8, and DE is 6. I'm going to cross multiply again. So I do 12 times my 6 gives me 72. 8 times my 9 gives me 72. These check out again, so all of them are proportional, so that's when we can make the statement that they are similar triangles. So then we need to see about GHJ. So I'm going to erase all this. So GHJ, I'm still going to do my smallest with my smallest, my largest with my largest, and then obviously my middle with my middle. So if I set them all up, I would do AB in comparison to the smallest over there of HG. Would need to equal my largest AC with my largest JG. And then my last sides that I haven't done yet, my middle ones, BC with JH. When I plug them all in, so I get 8 over 8. AC, I get 16 over JG is 16. And then BC, I get 12 over 10. Well, I can see the first two reduced down to 1, but this last one, 12 over 10, reduces down to be 6 over 5. Okay, that means that it's not equal, so these two triangles, the ones on the ends, these two are not similar. Whenever we have triangles that we want to try to make similar, then we're going to use variables, and we want to find the value of that variable that would make these triangles similar to each other. So if we notice in our similarity statement, it has A, B is first two, D, E is the first two, so I'm going to put those ones over each other. And that would need to equal my last two, BC, over my last two, EF. And then my outside ones, AC, over my outsides of DF. So now I can plug these in and try to solve. So AB, I have 4. DE, I have 12. BC, I have x minus 1. EF, I have 18. AC, I have 8. And DF, I have 3 times x plus 1. So I'm going to start off with these first two. I'm going to just cross multiply over here to try to solve. So if I cross multiply, I'm going to do my 4 times my 18, which gives me 72. I do my 12 times my x minus 1. It's very important when you do anything that has a plus or minus on the tops or the bottoms of these fractions, you put it in parentheses. So this will be 12 times that whole portion, x minus 1. So then I have to distribute. So I still have 72 is equal to 12x minus 12. Then I'm going to add my 12 to solve. And so I get 84 is equal to 12x. I'm going to divide by my 12 on both sides. And so I get x is equal to 7. And in this problem, since they both have x's, then this is just my answer. I don't have to set up again with the other one. I could check it. If I were to eliminate this middle portion and cross multiply using these two, using my 4 over 12 and my 8 over 3 times x plus 1, I should get the same exact answer either way. Then we also have side angle side. Side angle side is going to have two sides now that need to be proportional. And then it has to have one angle. The included angle needs to be congruent. Okay, remember included means it's right in the center because the A is in between the S and S. Then that angle has to be between the two sides we're talking about. So in this one they have XY, they're speaking on the right side here. Okay, and then they have ZX. Okay, notice the angle is between them. It touches both of those sides. Same goes for the other triangle. So if we look at this next problem, we want to use SAS theorem. So that means we need to have two sides in the included angle. So our included angle, you can see we already have this 53. That angle is congruent already. So we have our angle, but that means we need to use the two sides that are off of that angle. So it needs to be FG, would need to compare with one of them. And then off this one, these two sides as well. So FG would need to compare with AB. And it would need to equal our FH over our AC. Then we plug in our values. So FG we get 6 over AB of 9. FH we get 10 over AC of 15. So to try to show that they're similar, so we're going to try to show that they are similar to each other, so that way they actually, because it says that they are, it's assuming probably that they are, but we need to be able to show it. So to show they're similar, we need to be able to show that these would equal each other. These proportions would be, they would actually be proportional, so when we cross multiply they should be equal. So I'm going to do 6 times 15 to give me 90, and 9 times 10 gives me 90, so it checks out. So that means we have our proportion that we've already set up over here, where it says FG over AB is equal to FH over AC. That's a true statement, and we can show that angle F, is congruent with angle A, the included angle. So in this last slide, it's just showing you all these similarity theorems. Again, you need to have these written down. These would be a good thing to have, especially with proofs and stuff like that, as we maybe start to look at those again. These are how you would prove a triangle is similar to each other, and how you would be able to recognize if a triangle actually is similar, and being able to solve for unknown sides.